All right. Hi, everyone. Welcome to today's webinar hosted by Deepfence. Today's topic is understanding attack paths, the key to alert fatigue reduction and better remediation. I'm Ryan Smith, head of product and solutions at Deepfence. Today with me, I have Shyam Krishnaswamy, our chief technology officer. Welcome, Shyam. Appreciate you joining us today.
Hey, Ryan. Hello, everyone.
Excellent. Before we begin, I'd like to cover a few housekeeping tips. First, welcome to the webinar. All attendees will stay muted throughout the webinar today. However, the webinar is being recorded and will be emailed to you with slides after today's call. Feel free to use the question and answer in the Zoom menu. We've highlighted what that looks like for you to ask questions about the content at any time during the presentation. We may hold the answers until the end of the discussion today, but we certainly do want to take all questions that you might have as we go through today's content. So with that being said, let's go ahead and dive in. I wanted to start with what we think is an unprecedented security challenges that companies face when they move into hybrid multi-cloud environments or even single cloud environments, because the landscape of those environments has changed drastically, whether it's the types of infrastructure and hosting services available to you, whether it's the differentiation between IaaS, PaaS, and SaaS within the cloud, whether it's the just demands of the different hosting requirements you might have. This new complexity within these cloud environments, whether it comes from infrastructure complexity or application complexity, has caused us to need new detection methods for what we're deploying. So this has led to tool proliferation within the cloud environments. Enterprise security teams have on average 75 security tools that they've bought. I'm sure you could go through the categories of workload protection, firewalls, CASBs, CSPM tools, and you quickly realize how many tools you have within your own security ecosystem and budget. And all of these tools are spouting off alerts to the tune of greater than 500 public cloud security alerts daily that are reviewed by SOCs. So these tools are proliferating not only these alerts, but people have to respond to these. They have to either ensure that they're not false positives. They have to validate the alert they're seeing. And because teams have limited resources, limited time, limited money, limited subject matter expertise of those resources, they're missing alerts, right? Because they're having to swivel chair between 75 apps. They're having to review those with the limited staff that they have. And 55% of organizations have reported missing key alerts in security incidents, either daily, weekly, or hourly. So half of the companies out there are missing critical security incidents daily due to alert fatigue. It doesn't just impact our security posture, though. It impacts our resourcing and our people, and our efficiency within our security operations in dealing with different types of alerts. So 62% of organizations have said that alert fatigue has caused turnover for them within their staff. And we already know that security engineers, SOC professionals, analysts are some of the staff that's hardest to find within today's environments. And so they're losing critical staff that they can't hire back quick enough due to alert fatigue turnover. 30 hours out of a 40-hour week of a security analyst within the SOC is spent triaging alerts. That leaves just 10 hours out of your normal 40-hour work week where they can actually do higher level orders of activity, such as detection and response, instant remediation, forensics, threat intelligence analysis, security engineering. All of these other key functions of a SOC go underserved because we're just dealing with alerts all day. So not only are we dealing with alerts all day, but this causes burnout, fatigue, turnover. But there's hope here, right? The statistics the research, the data indicate that with proper risk prioritization, and what we mean by that is not just identifying vulnerabilities, but evaluating them according to their exploitability within the environment, 97% of alerts that we get from our security tooling can be reduced. So that, 30 hours a week turns into 1 hour a week of alert triaging, and it opens up so much more potential for our security teams to contribute in positive ways to our security risk and compliance posture that we didn't have before. So we're really excited to kind of dive into this topic a little bit today, but we think cloud security needs a little bit of a reset because, as we've seen, alert fatigue is off the charts. It's actively hurting your security resources and teams. Unfortunately, adding more tools and more software to the equation doesn't seem to help. It just creates more silos, more fragmentation within our security alerting and our detection and response. And so how do we really break free of this Sisyphean endeavor of, rolling up the hill, right, with all of these things? And that brings us to kind of the topic of today's webinar, which is that with attack path identification, management, analysis, etc., i.e. adding more context to the security scans and results we're getting in our environment, ultimately leads to better risk reduction and the ability to remediate those alerts with the proper controls. So you can better situate how your controls are performed in where they're needed within the environment. So you're effectively spending your security resources, whether those be technology resources or people resources. Deepfence approaches this issue of how do we identify attack paths by creating what we call to be the threat graph. And what the Deepfence threat graph is for us, and it's available across our product suite, is runtime context or security observability within your environment. And what we mean by that is we don't just scan your environment for where risk is, even though we identify what vulnerabilities you have, where you might have malware within the environment, exposed secrets within that environment, or even misconfiguration issues that could lead to cloud breaches. But we add what we know about the runtime context of the deployment of that application in the cloud, whether that be net flow information, who's talking to who, what that looks like, to create for you which of those vulnerabilities, malware, exposed secrets, misconfigurations is actually exploitable by a threat actor, and identifying and helping you map the actual attack path they would take to exploit that vulnerability. So the example we always give is, and Sham's going to show this later in the demo, is you might have two machines on the network that are both infected with a 0-day like log4shell and log4j, like we were all worried about last Christmas time. And, when you're thinking about remediating an environment that might have thousands of instances of log4shell like our customers, it's important to know which instances are actually attackable. So what Deepfence would do in that scenario is evaluate not only is log4shell in memory on that asset or that endpoint, but could a threat actor actually make the JNDI to LDAP server connection necessary to execute the remote code execution behavior that they would want as the outcome of exploiting that vulnerability? And if we can identify that attack path for you, we can eliminate all of the instances of log4shell for your environment that don't have that particular attack path open. So what this does is, when in a 0-day scenario, when you're scrambling to remediate your environment, find out whether you've been hit already or not, it allows you to prioritize where to put protections, where to put remediation efforts, where to spend your people resources remediating those assets, and not focus on the 97% of other instances that have that vulnerability, but aren't exposed or attackable in a way based on how a threat actor would use a particular tactic, technique, procedure. This also allows you to remediate those attack paths, which brings us full circle to how does this allow better remediation? Well, in those scenarios, we can put appropriate controls and coverage on the assets that have that attack vector available. And these choke points, ultimately do that. We're going to come back to that screen, these two screens here, but I wanted to kind of go into how this reduces alert fatigue and remediation. And then we'll go into a little bit of how we do it on the previous screens. So when we look at this threat graph, what this actually does for an environment is it takes, instead of all these instances of unique vulnerabilities that you might have, i.e. all those instances of Log4Shell within an environment, we drop it down to a list of the vulnerabilities that are actually exploitable within your environment, and then rank the exploitable vulnerabilities by severity, whether they have exploits available, CVSS score. So this gives you your hit list of which vulnerabilities do you need to actually remediate based on their accessibility and exploitability within your environment. And here you can see we have about 60% reduction of this particular environment, particularly in your high and medium vulnerabilities, which is where a lot of your vulnerability management teams would spend their efforts. And so we've reduced time spent here. We've reduced the effort on attack paths that wouldn't actually do. And we put a focus on what I call the choke points within the environment, which ultimately helps accelerate your security operations. And so if we can deal with and remediate along these top level attack vectors that might have other underlying assets, nodes, images within those things, then we can eliminate those types of attacks. And this is pretty typical, almost project management behavior that it allows security operations teams to undertake, right? Project management teams have different weighting. One of the most common is WSJF, right? Smallest effort, greatest impact is what that tries to do. And so if we can evaluate our high value targets within the environment by identifying these attack vectors, then our remediation efforts ultimately become that smallest effort with the biggest impact of security coverage and risk within our environment. And so this ultimately leads to better remediation within the environment, what we call security observability, because you get real-time visibility of those assets and a continuous assessment of their security posture based on that runtime real context, which allows you to make better management decisions, project management decisions around resource allocation, whether that be where do I put certain security controls? Where do I have to spend on security controls now that controls come often in a consumption model? Where do I need to target my people resources when I do patching efforts, when I'm looking at remediation efforts or forensics and response in a 0-day scenario where I've already been impacted or exploited? And ultimately, it helps us ensure compliance because all of this is continuous rather than point in time static snapshots of our environment. So it allows better upkeep of these things in real time. So once again, what is the key to security observability, attack path identification? Well, for us, it's these 4 pillars that really converge. And unless you're adding these 4 contextual pillars to your environment, then you're just getting vulnerabilities ranked by severity and CSPM results ranked by severity. And you're seeing all of these things in different platforms that you're having to swivel the chair. It's like putting together pieces of a puzzle, but you're missing like 4 pieces, right? In the end, you're going to have an incomplete picture of the, true coverage of the attack or what happened, because these data points are going to be in different systems. They're not going to have the same context associated with what's happening in the environment. They're going to be at different points of time. So for Deepfence, we really need to always think about measuring and contextualizing the attack surface of the environment with network flow information, cloud metadata, vulnerability, CSPM, malware scan results, putting all of this within a singular platform and system, evaluating what comes in and what goes out of an environment. So this is true traffic analysis and deep packet inspection, but targeted deep packet inspection, because doing deep packet inspection across all north-south, all east-west, all the time would be not only resource and time and money intensive on your infrastructure systems, but it just wouldn't be effective from, prioritizing how we spend our security resources. So that analysis of what comes in, what goes out, allows us to identify what's changed within the cloud, the applications themselves, the traffic, the process behavior, and better lead to security decisions. So Deepfence ultimately provides you a platform built on context. And, we kind of talked about alert fatigue earlier in the conversation. This is why alert fatigue happens in the first place, is because all of these fundamental controls, data analysis things, environment coverage, all of that complexity needs to be housed within a singular platform, a singular system that ultimately allows us to provide better security observability, attack path identification, and then ultimately remediation and coverage of the digital attack surface within our enterprise environments. The last thing I'll cover is, we've talked about the alert fatigue benefits, 97% reduction, which helps, ultimately converge along these items, right? Which is you're spending less triaging. That 30 hours a week becomes an hour a week. So for your average SOC employee, you're saving $1,500 a week of people costs just on that. When you total up this, cost savings, whether it be by consolidating all of those critical cloud alerts and contextual data points into a singular platform, or the people cost associated with managing kind of the alert fatigue that comes from traditional cloud security systems, platforms that approach risk reduction with attack path analysis ultimately can save 245 business days on average, roughly $300,000 a year. And that's significant, particularly in tougher economic times, when we're thinking about ROI of our security decisions. We really think that approaches around attack path analysis are important to cost and time analysis as well. And I'm going to dive into a demo, but I do think we have one question, which was just around sources for the statistics. And yes, we can provide the sources there in the notes of the PowerPoint when we send out the slides. So, that's various research from various studies, but each of those are outlined in the notes. So now we kind of wanted to shift today's webinar to a demo around how attack path analysis affects remediation. And Shyam's going to show kind of 2 systems within Deepfence and the differences between why attack path analysis is important. Shyam, over to you.
Thank you, Ryan. Hello, everyone. Thank you for joining us today. We did hear Ryan talk about what is attack path and why is it important, how it is built, right? Now, let's look at this attack path from a different perspective of what do we do with it next, right? Now that we have built an attack path, now that we have looked at various vulnerabilities, secrets, malwares, cloud scans, the scans within cloud services. What do we do with it next? What do we want to do with it? How does the attack path help us to be uh, have a better security posture, right? What I'm going to do now is I'm going to share my screen and we're going to look at attack path within our platform. And we're going to go ahead and see what would happen if somebody is trying to kind of take advantage of some of the exposed vulnerabilities or somebody who trying to exploit those vulnerabilities. How is it that we can protect ourselves when someone tries to exploit those vulnerabilities? Right. So I suppose you're all able to see my screen out here, right? So here is the attack path that exists within a sample demo environment. Now, this attack path, as I said, uses various vulnerabilities, secrets, the scans within the various cloud services to build out such an attack path. Now, to see this attack path in a little bit more detail, let's go over and look at some of the other results that feed into this attack path. For example, here is a set of vulnerabilities that are available to us from various vulnerable scans. In particular, we're going to take the vulnerability scan results for some of the containers to illustrate this attack path. Let's take vulnerability scans on our WordPress, MySQL, a sample log4j vulnerable application. Now, when we take the vulnerability scans of this, what we do is, as a first step, we look at these vulnerability scans result, and then their CV score, their reachability, what Ryan explained as a previous part, did the discussion around, I have a vulnerability, is it really exploitable? Which would mean that there need to be a multiple set of factors for this vulnerability to be actually exploited. The most obvious one is this vulnerability network reachable? Does this vulnerability have any known exploit? What happens next when this vulnerability exists within my system? So Deepfence by default provides a way to categorize all these vulnerabilities and answer the question of, is this vulnerability indeed exploitable? And to do that, Deepfence adds context, as Ryan explained earlier in his session. Adding context to any issues that we find helps us to prioritize the issue. As we can very well see from a large set of vulnerabilities, just by adding context, just by being able to understand the nature of a vulnerability, we are able to bring it down to a number where we can understand what is it that we need to fix first. Now, this is for vulnerabilities. Similarly, we pick in the secrets, we pick in the results of various cloud scans to build out this attack graph. Now, just a while ago, we just discussed about the results of various vulnerabilities and those results being fed into this attack path. Right? Here's a sample here. As you can see, there is a container here where this is a sample container where we see that there's a bunch of vulnerabilities which have been identified as being exploitable and which have a path to be exploited. Now, the reason why this container features here, but not the other MySQL or the WordPress containers, is simply because of the fact that those vulnerabilities are not directly exploitable. Now, in addition to this, this platform, the Deepfence platform, is also able to understand context here, which means that the vulnerabilities that exist within this container can be reached through another container, which is a HA proxy container, right? So which means that the vulnerabilities, not only is this platform being able to add runtime context, the runtime context is also meaningful here in a way that how can these vulnerabilities be exploited? What is the path to these vulnerabilities being exploited? And that gives us more, and this runtime observation gives us an ability to plot this for all the users of this platform so that they can focus those that really matter. So now, as we saw here, We did have vulnerabilities on few other containers, but the mere fact that those vulnerabilities are not reachable or they belong to a different class of exploitability, we were able to build out this attack graph, right? So now we have built this attack graph. We have looked at the various the risks within our environment. We have added a runtime context into all this to get here. Now here comes the next important part, which is what do we do with this, right? Now, the most obvious thing here is we have provided a tool for the security operations folk to start their remediation process. But then again, over the course of this remediation, as most of us know, remediation is not a one-day, one-time effort. It is a continuous process. Now, during this continuous process, how do we make sure or how do we ensure that the vulnerabilities that do exist in the system are not exploited? And this is where the runtime piece of the platform comes into play. What happens is follows, right? Ryan spoke about being able to focus and target our efforts of being able to understand what comes in and what goes out within the whole infrastructure, right? So what we can do is we go back here and we look at those systems that have the container that's running in, and we start the east, west, and north, south traffic analysis on that system. Now, at scale, you can always use the various APIs that we provide within this platform to be able to perform the same east, west, and north, south deep packet inspection, right? So let's take a quick look at what we mean when we do say mean the east, west, and north, south deep packet inspection, right? So earlier on, Ryan spoke about being able to target our efforts, right? So what we do is we look at the various processes within our system. We choose those policies that are receiving traffic, and we start the whole east, west, and north. So basically what comes in and what goes out. The two important pillars of the whole security observability on those processes that really matter. As a sample here, we have started traffic inspection on these two processes, which are the only two processes within the system. And we have specified it on a various set of attack framework. These are the various kill chain classifications and categorizations of your various aspects within your system. For example, I'm getting a remote payload. Is it a recon attempt on my system, right? I am getting a payload that is purely an SQL injection attack, right? So these are the various categories and classification within the whole runtime scenario. Now that we have started this whole east, west, and north south packet inspection, that would help us to build and that would help us to understand the various alerts or various events that happen in our system. That, for example, helps us to look at very low level payloads that come into our system like this that I've shown here, right? So now what happened was we built the attack graph. We then started the east, west, north, south packet inspection, and we are able to see such low-level information on what's going on and the various attempts to exploit those issues or those vulnerabilities, secrets, malwares, or compliance misconfigurations within our infrastructure, right? Now, going above and beyond this, we would also like a platform like this to be able to protect ourselves from these kind of exploitation. To that extent, we help to set some way security policy. Here's a sample security policy that is set within the system that helps to understand, for example, this is how you set the sample security policy, where you say that if a malicious payload is observed within the network, please go ahead and block the sender of the traffic to this network, right? We are able to set various security policies, and I'm just going to quickly show an attempt to exploit one such vulnerability. Now, we did see the log4j vulnerability coming up in our attack path. We also saw some previous attempts to be able to exploit the attack path. And here is a security policy that we have set that will stop any such attempt to exploit that vulnerability. Now let me go ahead and run an exploit, and we will see how we are able to block the exploit. Now I have here an exploit that is prepared. Let me just quickly show the contents of the exploit. It's a standard log4j exploit, and I'm going to start the exploit. Now, once I start the exploit, I do see that there's a kind of a response that I get here. And you will see that further communication attempts to this server has been completely blocked. For example, if I were to do a curl again to the same IP address, I would see that I'm being blocked here because a protection policy has been set. And as you see here, the IP address has been blocked for the next 10 minutes. Here is a log that just came into my system. A protection policy has been set and it has been enforced. Right. So this is the whole sequence that we are able to prioritize our remediation efforts, and we are also able to prioritize our protection efforts. We are able to set effective policies that helps us to block the senders of such malicious attacks and attacks. Back to you, Ryan, to continue the discussion.
Perfect. Appreciate that, Sean. Thank you for contextualizing for us everything that we talked about previously. It's always, at least from my perspective, better to see those things in action rather than just see a bunch of stats and slides about it. So I really appreciate the hands-on look of how Deepfence at least deals with attack path identification and how we use that to better target remediation efforts for our customers within the cloud. So great to see that live blocking of those zero-day scenarios based on that traffic analysis. I'm just going to bring up, one more slide, and then we can get into any additional questions people might have. But we always do want to share with you the ability to try out Deepfence now. We're largely loved by our community. We have over 5,000 stars across our products on GitHub. If you'd like to go into our GitHub and star any of our repos, we'd appreciate that love and support from our community if you thought what you saw was cool here today. Otherwise, you can get started with our products if you just go to the Get Deepfence link on our homepage. And then if you want to further engage with our community, read product documentation, get tips and tutorials, or check out our Slack channel, then click that last link, which will take you to our community page for further engagement.